Hello, my name is Matthew White, and today I'll be talking to you about nicotine-motivated behavior in C. elegans worms. And so just to give you a little bit of background on what's happening in my study, I used C. elegans for my experiment, which are very small microscopic worms. These worms are used in a variety of different drug studies for a multitude of reasons. Particularly with nicotine though, many studies have shown behavioral responses to nicotine in C. elegans that parallel the behaviors observed in mammals. This makes them very good test subjects for nicotine experiments and helps generalize the results to the real world. As many of you likely know, nicotine is a very popular drug in our society that can have a multitude of negative health effects. As a result of this, nicotine has been extensively studied. When it comes to C. elegans worms, many studies have shown varying results, especially when examining movement in nicotine. For example, one study found that different concentrations yield different movement behaviors. The largest concentration saw a decrease in movement, while the smallest saw an increase in movement. In many drug studies, the preference for the drug often wants to be determined by the researchers. To assess this, many studies utilize a chemotaxis index. A chemotaxis index is calculated by counting the number of worms in the desired area divided by all of the worms on the plate. The chemotaxis index indicates a preference or repulsion for nicotine with a score of 1 meaning a total preference for nicotine and a score of 0 showing a total repulsion for nicotine. A similar assay was done in another experiment that can be seen here. Despite mixed findings on the effects and preference for nicotine in C. elegans worms, I hypothesize that the C. elegans that were previously exposed to nicotine will likely exhibit much more movement away from the locations of nicotine compared to the control group. The subjects used in the experiment was a group of C. elegans worms, which had one that was previously exposed to nicotine for 24 hours prior to the experiment. The materials used started with the C. elegans being cleaned 3 times using a buffer solution and then were placed in test tubes using a dropper. The dropper was then used to put the worms on the testing plate, which was divided into 4 quadrants. 2 of these quadrants had been previously treated with nicotine, while the 2 others were made up of saline. A microscope was then used to observe and count all of the locations of the worms in their specific quadrants. Prior to the experiment, the C. elegans were kept in their respective conditions for 24 hours. Both groups of C. elegans were cleaned 3 times using different droppers to ensure that there was no cross-contamination of worms. The worms were then dropped onto the middle of each separate testing plate, and the remaining liquid was wicked up by a tissue to allow the worms to move more fluidly. The locations of the worms in each quadrant were recorded every 10 minutes for 30 minutes. These statistics on every 3 different trials were calculated using a two-way ANOVA. The average chemotaxis index for both the control and pre-exposure group exhibits a slight preference for nicotine, as the chemotaxis index was higher than 0.5 in every measurement. However, a main effect was not found for the interactions of the conditions and varying times, as well as the main effect of conditions. This signifies that prior exposure did not influence the preference of nicotine in C. elegans worms. However, there was a main effect found in time, which indicates that the chemotaxis index significantly increased over the measurements of time. This can be observed in the graph seen to the right in the 20 to 30 minute time mark between the control and nicotine group. The C. elegans that were previously exposed to nicotine did not exhibit significant movement away from the nicotine in comparison to the control group. In fact, both groups exhibited a slight preference for nicotine regardless of prior exposure. As a result, the hypothesis of the study was not supported. Now for some limitations that could be responsible for the results of the study. Only one concentration of nicotine was utilized. Varying concentrations could have resulted in different overall speeds of movement, as we saw in the previous study. The duration of the test may not have been long enough to assess preference. Many of the worms could have still been moving towards their desired location at the 30-minute mark. The number of subjects in the study were not standardized throughout each trial and were too small. All of these could have been responsible for the results that were given in the data. Now for some future directions based off the previous limitations of the present study. A future study that utilizes varying concentrations, longer time measurements, and a large standardized population could provide very interesting results that give insight onto the preference for nicotine in C. elegans worms and how prior exposure can affect preference. Other variables that could potentially be manipulated to change the results are the length of prior exposure to nicotine, time spent in the saline petri dish before testing, and the number of chemotaxis trials conducted. I would like to thank Dr. Clerical, my mentor, and Dr. Kiefer, my professor, for guiding me through this project and helping me whenever I needed it. Thank you for listening.